It is a bizarre reality we now live in. Beat. We are discussing insurance policies for rogue AI agents today.
Yeah, and blueprints for massive floating data centers out on the ocean.
It is incredible. Welcome to the deep dive. I am really glad you are joining us.
We have a huge stack of updates to unpack today.
We really do. We are entering the agentic era. So we are starting with OpenAI's highly anticipated GPT-5.5 Instant.
Right, which is changing everything about baseline reliability.
Exactly. Then we will navigate the wild new ecosystem of autonomous agents. We will look at the ocean-cooled data centers powering them.
And we finish up with a massive speed breakthrough from Google's Gemma 4.
But before we get into the weeds, I have to admit something. Beat. I still wrestle with prompt drift myself.
Oh yeah, everybody does.
You spend 20 minutes setting up the perfect parameters.
Yeah.
And the model just slowly wanders completely off topic.
Well, that wandering is basically structural amnesia. Older models just lose the thread of the conversation over long horizons.
Well,
But OpenAI just made GPT 5.5 Instant the new default. And the whole architecture focuses on killing those hallucinations.
I want to understand the mechanics there. For you, the listener using ChatGPT daily, how does this actually change your workflow?
So the memory feature for Plus and Pro users is entirely different now. It actively references past conversations. It pulls context from your uploaded files. It can even extract details directly from your Gmail.
Oh.
Yeah, but the fundamental breakthrough is the introduction of editable memory sources.
It's like stacking Lego blocks of data.
That is a great way to look at it.
If one block at the bottom is a hallucinated fact, the whole tower leans. Eventually, it collapses into a crazy answer.
Exactly.
But with editable memory, you can pull out that one bad red Lego block, and the structure stays sound.
That physical visualization captures it perfectly. When an AI lacks proper grounding data, it just makes statistical guesses.
Which we call hallucinations.
Right. By curating those exact memory blocks, you constrain its universe of answers. You force the system to rely exclusively on verified facts.
And we are seeing the results in the benchmarks. The AIME 2025 math test score jumped from 65.4 up to 81.2.
Which is huge. A jump of that magnitude signifies genuine chain-of-thought reasoning.
It isn't just regurgitating memorized test data.
No, it is applying logical steps sequentially. It never loses its place. This completely alters the landscape for high-stakes fields.
Like law or medicine.
Exactly, or finance. Those sectors simply cannot tolerate statistical guessing. A hallucinated legal precedent ruins a case entirely.
I do want to note a bittersweet development for developers, though.
The 4 retirement.
Yeah. GPT 5.5 is live and the API is chat latest. That starts a 3-month window before version 5.3 is retired.
Right.
But they also announced the permanent retirement of GPT 4.0 in February 2026.
The community response to that really highlights human psychology.
It really does.
Version 5.5 is technically superior across every metric. But users are genuinely mourning the loss of 4's unique personality.
Efficiency rarely wins over human emotion.
Yeah, some users describe 4.0 as a comforting digital friend.
BT. Let me pause and ask you about this editable memory structure. Does giving users direct control over their data sources actually solve the persistent hallucination problem?
It treats the root cause rather than the symptom. Hallucinations stem from a decaying context window.
Right.
When users actively prune their memory sources, they maintain a pristine environment. The model never has to guess because the context never decays.
So editable memory means we finally control the AI's evolving context. Got it.
And the broader consequence is massive. These reliable models don't need constant supervision anymore.
Because models like 5.5 are reliable enough to remember context, we don't hold their hands. We are moving away from passive chatbots entirely.
Yeah, we are.
We are entering this wild new ecosystem of autonomous agents acting on our behalf.
The industry is rapidly adopting the OpenAI framework for this. Google is actually testing a Gemini-powered agent called Remy right now.
Remy doesn't just answer questions, right?
No, it actively clicks, scrolls, and executes tasks inside your applications.
That is wild.
Perplexity just launched a similar tool called Computer. It sits directly inside Microsoft Teams.
So I can just tell it to build a dashboard.
Yeah, or draft a document. It just does the work in the background. It watches the chat interface. It gathers the necessary data.
Without you ever leaving the window.
Exactly. And the sheer speed of these coding advancements is pushing timelines aggressively.
An Anthropic co-founder just published a detailed analysis on this.
Right, predicting a 60% chance that AI systems will train their own successors.
Before the year 2029, that is less than 3 years from now.
AI can already write and test code exponentially faster than humans. When agents can self-correct, they iterate on their own architecture endlessly. Whoa, imagine scaling to 1 billion queries.
The compounding intelligence loop.
It would fundamentally rewrite the pace of technological history.
But because these agents act independently, they are inevitably going to break things.
Yeah.
Which brings us to Corgi.
The insurance company.
Yeah, they just launched an insurance product specifically covering rogue AI agents.
The financial liability of autonomy is a massive corporate blind spot right now.
If an automated sales agent accidentally offers a 90% discount, you lose millions.
Or if it wipes a core database while trying to organize it, the whole business halts. Traditional liability policies do not cover autonomous digital entities.
Because traditional policies treat software as a static tool. What is the actual legal reality of this rogue AI insurance right now?
Well, the legal framework is playing desperate catch-up. Corgi is using parameter-based coverage models.
Meaning what, exactly?
They assess the specific permissions you grant to your agent. The higher the autonomy, the higher your premium.
Makes sense.
It provides a financial safety net while courts figure out who is ultimately responsible for digital negligence.
Right, real financial damage means we actually need insurance for autonomous agents now.
And the scale of these autonomous operations creates a secondary crisis entirely.
With these agents scaling up, they run constantly in the background. That endless operation shifts the bottleneck away from software.
Yeah, we are hitting massive walls in government oversight.
And sheer physical power availability. Let's talk about the governance first.
Google, Microsoft, and xAI just entered into a formal agreement. They will share early AI models with the U.S. government for safety testing.
So the government tests them before any public release.
Exactly. We are also seeing new internal governance tools emerge.
Meta is rolling out systems to estimate user ages visually, right?
Yeah. The AI analyzes uploaded photos and videos to detect underage accounts. It looks at physical markers.
Like height and facial bone structure.
Right. It automates platform compliance without requiring hard identification documents from every single user.
Let's shift to the physical power grid. This is where the physics get truly intense.
The energy requirements are just staggering.
Peter Thiel just led a $140 million funding round for a startup called Panthalassa.
They are building 85-meter floating AI data centers?
These are basically massive ships sitting out on the open ocean.
Yeah, scheduled for a 2027 commercial launch.
They use kinetic ocean wave energy to generate their own isolated power.
And they pump freezing deep seawater directly through the server racks for cooling.
I have to push back on this.
Huh?
Are floating wave-powered servers a practical necessity? Or is this just billionaire sci-fi?
I know it sounds crazy, but the terrestrial grid is mathematically incapable of supporting the agentic era.
Because of the cooling requirements.
That is a huge part of it. Modern land-based senders require millions of gallons of fresh water daily just to keep processors from melting.
And they strain local electrical grids to the point of blackouts.
Exactly. The ocean offers infinite free thermal cooling. It offers relentless kinetic energy. You completely bypass municipal zoning laws.
We are also seeing a rapid evolution in the tools needed to manage this infrastructure.
Like Wadev Agent, it just launched to measure the actual return on investment for these AI calls.
Tracking API spend is critical when agents run thousands of background queries daily.
Right. Kilo Code version 7 also dropped this week. It introduces fully parallel agents.
Meaning multiple AI assistants code different parts of your project simultaneously. Let me ask you the feasibility of offshore data centers. Do saltwater corrosion and violent storms negate the cooling benefits?
They are massive engineering hurdles, absolutely. But replacing terrestrial water consumption and land acquisition costs changes the math.
The marine maintenance budget becomes viable.
Yeah. The cooling efficiency gained from deep ocean water far outweighs the structural upkeep of the hull.
So moving offshore solves both the cooling and the massive tower grid problem.
It creates an entirely isolated, self-sustaining loop of heavy computation. Mid-roll sponsor read.
And we are back. Building massive offshore data centers to power huge models is incredibly expensive.
Which means we need an alternative.
The alternative is making our local models radically faster and more efficient instead. Which brings us to Google.
The entire industry paradigm is shifting toward velocity right now. Google just launched Gemma 4.
And it is 3 times faster than previous iterations.
Yeah. The new governing philosophy is that speed is the actual intelligence.
Waiting for a 31 billion parameter model to generate text word by word, is agonizing.
It completely kills long-horizon agent tasks. If an agent needs to try, fail, and correct itself 100 times, it has to happen in milliseconds.
Google solved this latency issue using a fascinating two-model system called MTP drafters.
Right, which relies entirely on a mechanical process called speculative decoding.
I want to define that clearly for everyone listening. Speculative decoding.
Yeah.
A small AI guesses words. The big AI quickly checks them.
That captures the architecture perfectly. Instead of one massive brain struggling to calculate every single word, Gemma 4 splits the labor.
You have a highly agile, lightweight drafter model running locally.
Yeah. It throws out rapid-fire guesses for the next several words in the sequence.
And it does this without consuming extra hardware resources.
It shares the short-term working memory directly with the main model, so it uses almost zero additional hardware memory to make these guesses.
Once the drafter lines up a sequence of words, the heavy model steps in.
The massive 31 billion parameter brain.
The heavy model just acts as a lightning-fast editor.
It verifies all of the drafter's guesses simultaneously in one single parallel pass.
If it agrees, it outputs a huge chunk of text instantly.
If it spots a mistake, it corrects it on the fly. You get hyper-fast generation with zero drop in reasoning quality.
Right, and this is absolutely vital for local speed. You can now run these massive models on standard consumer hardware.
Yeah, an RTX 4090 or PRO 6000 runs it with near-instant responsiveness.
They also optimize specific versions like E2B and E4B for mobile phones.
When text generates 3 times faster, the phone's processor works for a third of the time,
which preserves your battery life significantly. Why does this localized speed matter so much for autonomous agents?
Because true autonomy requires continuous background computation. An agent might read a document, search the web, and write a summary.
All in a single loop.
Right. If each step takes 5 seconds, your phone freezes and the battery dies. If it generates instantly using speculative decoding, those 1,000 microsteps happen in seconds.
Fast generation means agents can do thousands of background steps without draining batteries.
Google essentially proved that we don't always need offshore data centers. We can just fundamentally rewrite how the software thinks.
We have covered a massive amount of ground today. Beat. We journeyed from GPT-5.5's pursuit of zero hallucination reliability through editable memory.
We explored the new ecosystem of autonomous agents.
We examined the bizarre reality of rogue AI insurance policies and floating ocean data centers.
And we broke down how hyperfast models like Gemma 4 make this era possible.
Every technological breakthrough we discussed inherently solves a bottleneck created by the previous one.
The reliability of memory creates agents. Agents create a power crisis.
And the power crisis drives the need for hyperfast local models. Beat. I want to leave you with a final thought to mull over today.
Okay.
It is a philosophical question based entirely on the mechanics we just explored. Imagine that hyperfast lightweight drafter model guesses a rogue action. Then, the heavy model accidentally verifies and approves that exact rogue action. It goes out into the real world and causes massive financial damage.
Wow.
Does the rogue AI insurance cover the small drafter model? Does it cover the heavy model that ultimately approved the mistake? Or does the final legal liability still fall entirely on you, the user who pressed start?
The legal system is going to spend the next decade untangling that exact scenario.
It truly is.
Yeah.
I highly encourage you to audit your ChatGPT memory sources this week. Look at the exact Lego blocks of data the AI has collected about your life. Take control of that evolving context. Thank you for spending your valuable time with us today. Keep questioning the technology around you. We will see you on the next deep dive.